Hello and welcome to PB Edu YouTube channel. Here we solve all your doubts or queries related to your school chemistry. Today we have a question of amines. The question is, which of the following amides will give ethylamine on reaction with sodium hypobromide? So, here we are given a lot of amides. So, amides, the general formula of amides are RCONH2. And the other reactant or the reagent is NaOBr. And the product form should be ethylamine. Ethyl means two carbon atoms, C2H5, and here would be NH2. So first of all, we should know the mechanism for this reagent. So along with amide, when this reagent NaOBr, sodium hypobromide, reacts with amides, sodium, this reagent is given hypobromide. So for the mechanism, we will again write this. General formula of amide RCONH2. And here we will write NaOBr. So in NaOBr, this oxygen has lone pair of electrons. So what it does, it attacks on the hydrogen atom bonded to nitrogen group. So it will attack and abstract it. And if it is abstracting, hydrogen will give its electrons to nitrogen. Therefore, nitrogen gained electron, there is more electron density, it is more electron rich, while this bromine has electron lost because this bond is broken, the oxygen and bromine bond is broken, therefore it is electropositive. So, the product for this step would be RCONHBr. This Br has come from NaOBr. We can write it in red. NaOBr plus NaO. So the NaO and the hydrogen has come from the amide. So now we have this group and along with a strong base. NaOH is a strong base. So what it would do? It would abstract this hydrogen also. Nitrogen has one lone pair of electrons. Now this would abstract one more hydrogen atom and hydrogen will give its the bonding pair electrons to this nitrogen atom. So R, C, O, N, there are two lone pair of electrons and negative charge along with Br bond. So here what would it do? This is unstable molecule. So the nitrogen because nitrogen has a lot of electron density, it would shift one of its lone pairs on this carbon forming a pi bond with carbon, and this carbon can only form 4 bonds. Therefore, this alkyl carbon bond would be broken and this alkyl group will form bond with this nitrogen atom. And nitrogen can form only 3 bonds. Therefore, this bromine will leave from here. So, the bromine group will be leaving. Bromide as bromide ion. And next structure we will get is R, N, double bond C, double bond O. R is bonded to nitrogen and this nitrogen is bonded to carbon and this carbon is bonded to oxygen by a double bond. This is alkyl group, you can see R, isocyanate. So in water there would be, in reaction medium there would be some water and it would undergo hydrolysis of nitrogen carbon pi bond. The pi bond would be broken, only the pi bond would be broken here, and the nitrogen will form bond with hydrogen of water and carbon will form bond with OH of water. So the next structure is R, N, H, C, OH, double bond O. So this structure is not very stable. So the carbon dioxide would be leaving CO2, this CO2 group. would be leaving, and this RNH2 will form this primary amine. We got a primary amine as the product. So if we see the reactant, there was RCONH2, and in the product there is RNH2. It implies this CO group has been removed. It implies that whenever an amide will react with sodium hypobromide, the CO group will be leaving and we will get a primary amine as product. So in case of butanamide, we have butanamide, propanamide, acetamide, like this. So in butanamide, there is 4 hydrogen atoms, C4H, the C4H12 in alkane, so there is C4H11, CONH2, and the product would be C4H11NH2, which is not the required product. Ethylamine, it is not ethylamine, therefore this option is incorrect. Next is propanamide, C3H5CONH2. So the product would be C3H5NH2, which is also not the required product. This option is also incorrect. Next is acetamide. Acetamide is also called ethanamide. Therefore, in ethanamide, there is 2 carbon atoms. So C2H5CONH2. In propanamide, there was C3H7. So the product is C2H5NH2, which is the required product, that is ethylamine. Therefore, this option is correct. And next is benzamide. So in case if we talk about benzamide, it means amide on benzene ring. So that can also not be the product. We will not get the required product. So this amide is CO and H2. And if we add NaOBr, the CO group would be removed and we will get like this aniline, which is also not the required product. Therefore, this option is also incorrect. The correct option is option C. If you like this solution, please click on the like button. And if you want more such solutions, and if you want to ask any of your queries, you can ask in comment section below. If you want more such solution, please subscribe to PBEdu YouTube channel.